All right, let's do some Mathity-Math. It says here, prove that the given straight lines pass through the same point. Okay, so we have these three equations, and they're saying prove that they all cross on one singular point. And the way you can do this is just to find the point of intersection for two of the lines, right? And then plug that answer in and make sure it works. Now I'll show you the whole process. You could try to take two and combine them and eliminate, but I think for what we're doing, I think it'll work better if we just first shift everything into slope-intercept form, or into y equals mx plus b form. So let's just go ahead and go through the process here. We want to first get this y term all by itself, so I'm going to add 21x to both sides. So I'd say 3y is 21x plus 6. And then the next step is I divide everything by 3. And so I would get y is 7x plus 2. Okay, so this is like my y equals mx plus b form right there. And that's great. Let's do it for all three, just to have it done. Okay, so step 1, I subtract 2 from both sides. So I got 8y is negative 2x plus 248. Keep it going. Next step, divide everything by 8 to get y all by itself. So I get y is negative 2 over 8x. 248 divided by 8 is 31, so plus 31. You can use your calculator for that. It's right here, just like I did. See, 248 divided by 8, 31. Great. Keep it going. Let's see here. So we have negative 2y is, we subtract 8x from both sides, minus 8x minus 28. Next step. Divide everything by negative 2. Y is negative 8 divided by negative 2 is 4. And negative 28 divided by negative 2 is positive 14. Okay, so that's a good first step. We put everything into slope-intercept form, and that should make our life pretty easy. At this point, you can use the idea of y is equal to y, and that's when two things cross, they are equal. So we say, well, y is y, and that lets us substitute in. So instead of this y, I'll say 7x plus 2. And instead of this y, I can say, instead of negative 2/8, I'll say negative 1/4 x plus 31. And if you're more comfortable as a decimal, you could say that this is negative 0.25. That's fine. We'll go from there. All right, so now we have only the x's to deal with. So if we isolate this x, we'll find the x value of the point of intersection. So let's do that. I'm going to add 1/4 to both sides, and this is why you might prefer to do a decimal. If I add 1/4, I'll have 7.25x equals, if I subtract 2, 29. Divide both sides by 7.25. Let's see what happens here. 29 divided by 7.25. Lovely. It is 4. I don't know if you can see that. It's 4. Okay. So we know that x is 4. So for our point of intersection, the x-coordinate is 4. Now, to find the y, you just plug that 4 in. And we can kind of prove the whole thing at this point in a little bit. You'll see what I mean. In some ways, it's kind of dumb, but we'll do an extra step to, I guess we'll double prove it just to be safe. Belt and suspenders, as they say. So if we plug in this 4, let's do it to all three and see what happens here. So you'd say y is 7 times 4 is 28 plus 2. So that gives us y is 30. Okay, so that should be the point of intersection. But what if I had tested this one? Okay, I'll plug it in there. Y is, so if I put in a 4, right, you would have 8 over 8, that is negative 1. So you'd have negative 1 plus 31. Okay, and that would give you, well, y is 30. So you're kind of proving it right now. But keep it going. This one, y is, okay, if I plugged in x, 4 times 4 is 16. That's a 14, and 16 plus 14 is 30. So look at that. We got the same thing every time. So that actually, you could say that kind of proved it right there. But if you want to be extra super duper sure, you could plug in your x and y to all three and see what happens. So I'll go ahead and do it. I'm going to make like my super safe line here. So I got y is 7x plus 2. That's my first one. I got y is negative 1/4 x. To be clear, I just simplified. Okay, plus 31, and I have y is 4x plus 14. And so I'm just going to plug in my x's and my y's and check that all three of these lines actually hit that point and they all intersect at that point. Okay, y is 30. 30 equals x is 4. 7 times 4 plus 2. That's 28 plus 2. So I just said 30 is 30. Well, 30 is 30. Woohoo! Step 1, check. Okay, plug in my y. 30 equals negative 1/4 times 4 plus 31. So that's saying negative 1/4 times 4 is negative 1. Negative 1 plus 31 is 30. So I just said 30 is 30. Woohoo! That one checks out. We are proving all over the place. Here we go. 30 equals 4 times 4 is 16. 16 plus 14. 30 is 30. Woohoo! And that proves it. Now, if at any point, like you would have gotten a number that, or an equation that was not true, like what if you'd have gotten 29 equals 30, then it doesn't, it's not okay, right? But because they all made valid equations, that means we did good work, and we have proven that these three lines all go through the same point, and that point was 430. Wow. Cool. All right, guys. If you have any questions or comments, leave them below. I'll do my best to answer them. And as always, if you want to be notified when there's more Mathity-Math, go ahead and subscribe to Mathity-Math. Bye!